I'm Dror Sapir, and this is Lab 4, Optimal Beam Collimation and Testing Radius of Curvature. So why did we do this lab? In previous labs, we focused on advanced characterization of beams, which requires the ability to properly collimate a beam. Beam collimation is not an absolute in the lab, but rather a property of the beam. Lab collimated beams do not keep their beam diameter like spatially filtered sunlight or moonlight. They're expected to remain collimated to a high degree for distances made relevant by the experiments done in lab. The lab focused on the ability to quickly reach a high level of collimation and to verify the quality of the collimation. Here's what we did. First, I determined the correct expansion ratio and the size of the spatial filter. I then assembled the mounts and the other components. I aligned the laser to the rail as well as the lenses and other components. I then slowly walked the laser around the pinhole until it went through. Once the laser went through the pinhole, I made fine adjustments to eliminate the outside circles and be left with a large, well-defined circle. The translation fine adjustment on the pinhole mount had to be adjusted until the large circle was as bright as possible. The light was collimated before reaching the shear plate, where further adjustments were made to increase the extent of collimation. We used this setup to do radius of curvature and focal length tests. In some results, the focal length of the low power lens is about 81 millimeters. The light collimation has been done multiple times with multiple results on the shear plate. The best collimation result was when the fringes were far apart and relatively horizontal. This is seen in the picture on the bottom right. Some of the optics aren't in good condition, and getting the curvature out of the fringes was not possible. In conclusion, collimation is an important skill that optical engineers need to be good at. I find it a bit difficult to verify good collimation in lab because of imperfect equipment, but I believe I have mastered the procedure and do it well. The contest at the end of the lab was a good metric for how well we can collimate. While I wasn't the fastest in lab, I believe my time of 4 minutes and 29 seconds is more than adequate and would have been even shorter if I didn't double check the collimation myself. Overall, the lab was a success, and the skills from the lab can be used quickly for future labs.